This video is about a very simple statement that I greatly missed when I began studying fluid mechanics. The statement is that fluids respond to things. Let's check it out together. As you begin studying any kind of flow in fluid mechanics, you may feel in turn puzzlement, wonder, and dread, because you rapidly realize that any simple flow, really like something as simple as pouring a drink in a glass, can produce extraordinarily complex flow patterns. And it's hard to know where to begin, how to approach the problem. For this, I have two main ideas I'd like to communicate. The first idea is that fluids flow relative to solids. It's not a general statement about the physics of things. It is a way to approach a problem so that solving it becomes easier. Imagine you are standing outside on a beautiful day and you're looking up and an airplane is passing by. An airplane is a solid machine that's moving through a fluid, air. And you can very well imagine, I think, if you just sit here and look at the patterns, or imagine the patterns around the airplane, that they're very complex. And describing this movement of the air around the airplane will be very difficult if you have a stationary approach, where you're on the ground or in the air and see the airplane passing by. It will be a lot easier if you, in your mind, attach your point of view to the airplane and see the flow passing around the airplane. So the approach of the passenger, having a nice drink, looking up at the window, and seeing the flow pass by. This is the beautiful river Elbe in Magdeburg, where I live, and you might be observing the movement of the water sitting on the banks, or you might jump on an imaginary raft that is floating on the river and observing the same flow from the point of view of the fluid. And that point of view, here, the bottom of the river, a solid surface, is passing below you as you float down with the river, and so are the banks on the side. This is the same flow, these are the same physics, it's the same effect. But certainly describing the movement of the water will be a lot more difficult if you are floating down with it than if you stand on the side and see the fluid pass. The second idea that may help you approach a problem, to build on the first one, is to think that fluids move and they respond to forces. This might be very obvious to state, but simply formulating this thought can greatly help you move along. At this point, it's worth pausing for a second and asking ourselves the question, like, how do you determine the movement of anything in physics and engineering? Well, the method for this is now very mature, and it's always the same. You start by observing your object and determining all the forces that apply to it. Once you have all the forces, you add them up. The sum of all these forces together determines the acceleration of the body. And then the acceleration is the change of velocity. It's always the same thing. So if you want to determine, say, the acceleration of a race car, or you want to determine whether a boat is going to capsize, or you want to calculate the radius of the trajectory of an airplane maneuvering through the sky. In all those movements, it's always the same thing. You look at the object, you determine the forces that apply to it. The sum of the forces divided by the mass is the acceleration, and the acceleration is the change of the velocity. With this, you know where they're going, where they are at any time. I must point out here that it's important to think of velocity and acceleration as vectors, which means they don't have just a length, they also have a direction. Let me show you. Take a simple pendulum. The pendulum just swings back and forth. This, by the way, is a simulation from FIT, from the University of Colorado. You can find it online and play for hours with it. The green arrow shows the velocity of the pendulum. The change in time of that velocity is the yellow arrow. That's the acceleration. And you should see that the acceleration and the velocity have completely different directions most of the time. Do take the time to play with this and revise these notions of velocity, acceleration as vectors. By this I mean not focusing on the equation of motions of a pendulum, that's not interesting, but extracting from this the general method. In the case of fluids, the great news is that there are only three kinds of forces that apply on any fluid particle at any moment. And the forces are as follows. Gravity, something that causes it to fall. Pressure, it is the pushing effort of its neighbors around on the sides, above, in front, and to the sides. And shear, which is the rubbing effort, again, of its neighbors on all the sides. Fall, push, and rub. How simple could this be? So next time you observe a complicated flow, a beautiful flow, like here, the clouds passing over the mountain. There are many processes at hand over here, and it's a very complex flow pattern. As you're observing this and feel puzzlement or even dread looking at this, remember, in your mind, just identify any one particle, any fluid particle in this flow, and think that on this particle, there are only three kinds of forces: pressure, shear, and gravity. So, you start studying a flow, it's mesmerizingly complex. Where do you begin? Well, relax. Fluids respond to things. We determine their movement exactly the same way that we determine the movement of anything else. Namely, we take a particle, and on this particle, only three kinds of forces can apply. These are gravity, pressure, and shear. Once you have these forces, you add them up together. The sum of these forces, divided by mass, is acceleration. And once we know the acceleration of the particle, we determine the speed, because acceleration is the change of speed. And then with the speed, we determine the position, because speed is the change of position. This, I hope, is a good first approach to think about the movement of fluids. I look forward to dive a bit deeper into this with you in the coming videos, and I'll see you in the next one. Hi, I am Olivier Kleine, and I'm recording a video course in fluid mechanics. If you find this video useful, check out the rest of them at learnfluidmechanics.com. I hope to see you there. Take care.